I'm going to talk about digital data storage through DNA sequencing. Today's world is centered on technology. Every day, new technological advances are being made. Huge quantities of digital data are being stored daily, but it is becoming increasingly difficult to store all of this data. There are limited ways of storing data. Two examples include hard disks and magnetic tape. Both are used frequently, however, they both have their downsides. Hard disks consume a large amount of electricity and they cannot function without a constant source of power. They have frequent data error rates and they can be hard to recover data from. Magnetic tape, on the other hand, requires no source of electricity. However, it is known to degrade after years of use, and data can often be corrupted if it is placed near a strong magnetic field. Although these methods of data storage are reliable, scientists were interested in developing newer and more efficient ways to store digital data. In the past 2 years, new research regarding DNA sequencing has been discovered. Scientists discovered that 700 terabytes of data can be stored into a single gram of DNA. That amount of data is equivalent to 14,050 gigabyte Blu-ray discs in a droplet of DNA. This single piece of evidence proves how much more efficient DNA sequencing is to the other modes of storing data, such as hard disk and magnetic tape. With recent advances, analyzing a human genome has been cut down from years to multiple hours. DNA storage may not be as fast as other modes, but it is not nearly as disposable as other ones. With this new advancement, scientists anticipate a world where DNA sequencing will allow the world to record anything and everything without worrying about where it should be stored. In 2013, Nick Goldman and his colleagues at the European Bioinformatics Institute conducted a similar experiment to that of other scientists. These scientists have stored text, images, and speech into a small amount of DNA and then reclaimed it almost flawlessly. Goldman and his colleagues stored digital information by encoding it in the four different bases that make up DNA. However, DNA does not have a RAM like other storage devices. Consequently, there is no specification as to how to access data through DNA. Despite this setback, DNA still has its advantages. It is dense and therefore can store a huge amount of data, and it is extremely durable. It is known that DNA is long-lasting because DNA is still being extracted from bones that are tens of thousands of years old. Goldman and his colleagues used DNA that was produced in the lab as a way to prevent any mutations or data loss. The scientists were able to store data and synthesize DNA. But it is important to realize that this same process can be done in living organisms. By imitating nature, scientists are certain that DNA is very stable and can be used to its full capacity.